Hello guys, welcome to once more to class online. My name is Todami, and in this edition we are looking at Jamb Physics 2017 and 14, question number 21 to number 25, and we shall be dealing with some aspects of physics that will better help you understand physics. I always believe that Jamb Physics is what anyone can know as far as it is well explained. Now let's get to the video. Don't forget that if you learned something from this video, click on like button. We really want to reach you with loads of content that will help you clarify a lot in physics. Now let's go to number 21. Number 21 says the equation PAVBTC all to the power of ABC, okay, constant reduces to Charles' law if what? Now for you to be able to answer this question, you must remember Charles' law. Now what's Charles' law? Now here it is. Charles' law, it says that what? Volume is directly proportional to temperature, and that's at constant pressure the volume of a given mass of gas is directly proportional to temperature. And now I'll say it again, at constant what? Pressure, the volume of a given mass of gas is directly proportional to its temperature. And this is the simple way. I don't memorize formulas. I am sorry laws. I don't memorize laws. I only know the formula. Once I know the formula and I see the formula, I will naturally remember the law. And that's just it. And that's one of my little secrets in physics. So now, just know that this law reminds me, this formula reminds me of Charles' law automatically. So all I have in my head is this formula. And when I look at it, I remember the Charles' law. So now, this V is directly proportional to T. That's the Charles' law. Now, equals to, this directly proportional must change to mathematical symbol, equals to K, where K is the constant, okay? Now, V equals KT, and this equals to and K came from this proportionality. So that will give me, now making K the subject, I'll be having K equals V over T. That's if you divide both sides by T. So K equals to V over T, right? Now that will now give me V1, T1 equals V2, T2. But you know, Charles' law is all about that. You will change it from here to here if you are calculating with Charles' law. But I'm not calculating. They are just asking about this law. What is the Charles' law? So it will be this V over T, and that is just it. But is there P? Now, how will you express this in the question we were asked? Now, this means that V is 1 because V is on top. That means that T is minus 1 because T is under. You know, by the law of indices, over means negative power. That's over means minus 1. So that's V is 1, that's positive 1 because it is on top. Over means minus 1 for T, and that means minus 1 for the T. But P raised to power 0 is the one you will choose because there is no P. Okay, so to tell them that there's no P, you have to put P raised to power nothing because P doesn't exist. So that P can be what? Can be eliminated. That's because P is pressure, while T is temperature, and V is what? Volume. So now, volume, so Charles' law says that volume over temperature. That's just Charles' law. And that is V over T minus 1. But there's no P, so P raised to power 0. And that makes the answer to become C. That means that P is raised to power 0. That's my A is 0. Then for my B, volume is 1. And my C is minus, and my T, sorry, is minus, as minus 1. And that is the answer to number 21. Number 22, the quantity of heat needed to raise the temperature of a body by 1 Kelvin is the body's what? Now, what do you think? Which of these is defined as the quantity of heat needed to raise the temperature of a body by 1 Kelvin? Do you know? If you don't, I'll tell you. First of all, we have what we call latent heat. Is the amount of heat needed to change the state of a body from solid to liquid or liquid to gas. This is a good definition of latent heat. But it is the heat that change. Like if you have ice block, or we just say ice, and you are changing it into liquid, okay? Now, that heat needed to change state from solid to liquid is latent heat, okay? Or liquid to gas is latent heat. But that's not what the question is asking me, so the answer is not latent heat. Heat capacity is the amount of heat needed to raise the temperature of a body by 1 Kelvin, and that is the perfect definition of what we are. So the answer is heat capacity. Now let's check out internal energy. Internal energy is the energy associated with the random motion of molecules. The energy of molecules in motion within a body are called the internal energy, but that's not the answer. Then specific heat capacity is very close to the answer. is the amount of heat needed to raise the temperature of 1 kilogram of a body by 1 Kelvin. The difference between heat capacity and specific heat capacity is that specific heat capacity said to raise the temperature of 1 kilogram of a body. It was specific. Okay, 1 kilogram of a body by 1 Kelvin. Unlike heat capacity is just saying to raise the temperature of a body. How much of the body? We were not told. So that's the difference between heat capacity and specific. Specific must mention 1 kilogram of a body by 1 Kelvin, and that is just it. So the answer is heat capacity, easy peasy, full stop, and that's just it. And let's check number 23. The melting point of a substance is equivalent to its what? Now melting point and one of them are at the same temperature range. That's what we mean by equivalent. Now what I mean is that melting point, water melts at the same temperature it also what? Do you have any idea which one is right? Melting point and one of them, is it solidification temperature or liquidification temperature or solidification pressure or vapor pressure? Do you have any idea? Now the answer is very simple. Can you see that? Melting point is the same as what? Freezing point. It happens at the same. Now this is water. Okay, this is a solid ice. When you eat it, it starts increasing in temperature. It will get to 0 point and it will start melting. Okay, when it melts, if you keep eating it, it will start increasing in temperature. It will get to 100, it will start boiling, and when it boils, it will boil and change into steam or vapor. Okay, that's steam. Now, but backward, it can also cool. Okay, when air or steam cools, it condenses back into water or boiling water. It comes lower. If it keeps cooling, it will come into ordinary water. At the point it will get to the freezing point and start freezing into solid because it is cooling. That means it is losing it. It will lose it until it become ice. And ice means a body doesn't have heat. So ice is formed by the removal of the sucking out or the ejecting of heat from a body. If you take a fish and you keep removing it from that fish will become frozen. So the reason why things get frozen in the freezer is because heat was absorbed totally away. So the more the heat is taken away from them, the more frozen they get. And that is it. So melting point is the same as the freezing point or the solidification. You know, when it becomes solid, so it is the same as the freezing point or the solidification temperature. And that is the answer, because at freezing point it solidifies, it becomes solid like ice, and that is the answer for number 23. So notice that it at the same temperature it melts and backward it freezes. So when it is heated it will melt. That ice will melt, but if it melts into water, if you cool it at the same temperature, it will freeze back. The first is the temperature at which the water vapor present in the air the temperature at which the water vapor present in the air is just, that should be a is just sufficient to saturate the air. Okay, it's not is. Just sufficient to saturate the air is what? Now, what is the temperature? What is the definition of this thing? The temperature at the water vapor in the air is enough to saturate or to go around the air. What's it called? Is it ice point, saturation point, dew point, or boiling point? Do you have any idea? When water in the air covers the entire air, like what you have when you are talking about, I said it before, the answer to that question is just dew point. And the reason I said it in a previous video, that dew happens in the morning because of water in the air that is cooling. When water in the air cools, it forms dew, and that is just it. So the answer to that question is dew point. It's the temperature at which the water vapor in the air is sufficient to go around the air. When it goes around the air, it becomes and this is what you have here, dew on the leaves. So the dew point is when the water in the air is sufficient to cover the entire air. So we see that air is at dew point, and that brings us to the answer as C, dew point. Let's talk about number 25, the last one for this video. We have heat transfer by convection in a liquid is due to the what? Now, you've heard about conduction, convection, radiation, and you can always use the boiling water to explain all of them. Conduction has to do with heat transfer, right? By contact, by bodies in contact. Like if you put your hand in contact with the top of the pot that is hot, the heat in the pot will transfer to your hand by conduction, because conduction has to do with the transfer of it with by bodies in contact. Okay, then we talk about convention. Convention has to do with the transfer of it by the movement of molecules. Now inside liquid, like inside that pot that is boiling, there is water. Now the water keep rolling and boiling until it start bubbling. Okay, now convection is the transfer of it by the movement of molecules. Now think of this. Think of this for a minute. The water is boiling, right, at the bottom, at the lower part, right? Now the heat at the lower part is, that means the lower part is hotter, and then the upper part is cooler when the water is, when you put heat around the pot. Now the water below gets hot and goes up, and the one on top gets which is on top will have to go down, because the one below will go up. Now this is what happened. So this question is asking, how does convention occur? Heat transfer by convection in the liquid is due to what? How does it occur? Is it by increasing the vibration of the molecules of the liquid about their main position? Like if you are boiling water, are the water molecule vibrating in one position? No, they don't vibrate in one position. Liquid are not in a main position, they move, so they are not in a main position. So A is wrong. Variation of density of the liquid, is that correct? Is it because of the difference in density that the water roll? You know, when water is boiling, it's roll. That rotation of the water is called conventional current. So the hot water goes up, the cold one comes down. Is it because of the density, or the expansion of the liquid as it is heated, or latent heat? Now the answer is very simple. When water is being boiled, the hot water, that's the one below, is hot. Now hot things are lighter, cold things are heavier. Now it is a function. The reason why the water roll, that means the water keep bubbling up and down, is because of the density. The denser or the heavier one goes down. That means the cold water goes down and the hot one goes up. And when the hot one gets up, it begins to cool. So if it begins to cool, the one below that is cold, that was cold before, will get hot and will turn again. So water always turns this way. Boiling water turns this way, and it keeps boiling and boiling and boiling and boiling. And it is by the rotation of density of the water. The hot one is below, the cold one is on top. But as the water gets hot below, the hot one gets lighter, because all things are light. Even air, hot air is lighter, cold air is heavier. So the hot water is lighter, it will be forced to go up, while the heavier cold one will be forced to come down. And when it comes down, it gets hot and becomes hot, and it becomes hotter than the one on top, so it goes up, and the one on top, which was hot before, now cool, will come down to get hot. So that's the way it continues to rotate, and then you have a conventional current system is formed, and that will now give us our answer. So the answer is because of variation of density. The water, some of them are denser or heavier than some, and that is and that's the reason why we have convention in liquid, and that is the answer for that question. Don't forget, if you learn anything from this video and you want more content that will better help you understand physics, click on the like button. We have lots of content to share with you that will better help you clarify physics. Until we see you again, guys, take care of yourself and bye for now.